Hello everyone. We will begin in a while. Let me just check the audio first. Yes. So let me just double check. Mm, Yes. So the audio seems to be working now. We had some issues in the last live session. So yeah, we've tried and fixed those audio issues. Okay, so let's just wait for everyone to join. We'll wait for 1 minute and then we'll start with the session. So yes, so I guess we are good to go now. We'll begin with the session. So the topic is scrolling plots in Python. So this is our topic, scrolling plots in Python. Okay, so how I have divided this session is, first we'll briefly understand what are scrolling plots, and then after we have understood what are scrolling plots, we will proceed with the rest of the sessions, which is installing the requirements, and then once the requirements are installed on our system, then we'll move with the realization or the code section. Okay, so let's just see all the steps one by one. What are scrolling plots? Okay, so scrolling, you would have definitely seen regular plots, right? Like you would have definitely, if you have used Python, you would have seen some plots, right? So how do we, what does a plot consist? It contains a value which needs to be plotted, and then it contains the number of samples. That's how a basic plot is defined. If you see carefully, in normal plots, these values are defined, they are static. So let's say I am plotting 10k points or 100k points or 1k points. So this number of points that we plot is fixed, right? So these are called static plots. I mean, I wouldn't call them static, but their nature is static. The nature is static as in the values or the number of samples that you have defined is same. It remains the same for each plot. Your data is not dynamic, it is static. So let's say I want to plot y equals, let's say I have these values. So let's say I have 1, 2, 3, 4, 5. If you want to plot this, you will get a straight line, something like this. So what I am trying to say over here is my values of y are fixed. My 1 is not getting changed, my 2 is not getting changed, my 3 is not getting changed. Same with 4 and 5. I have fixed that I want to see 1, 2, 3, 4, 5 as a plot, and that's how you generate a plot. You will get a straight line, and then you just want to see the nature of this curve or the shape of this curve. You are just interested in the shape of the curve, right? So the values are fixed, you get a plot, and then you're okay with it. That's it. Now what happens in a scrolling plot is this size of y remains constant. Okay, if I say that I want to plot y equals 1, 2, 3, 4, 5, then this is a data structure, right? This is a data structure or an array. So even in scrolling plots, size of this data structure or array remains constant, but the values will change. So let's say I started with 1, 2, 3, 4, 5, then maybe in the next iteration or after some nth time, this value will change. This fifth or the last most element will be changed, or you can change it from any end. Either you can change from this end, and either you can change from this end. Okay, so what I'm trying to say is I started with some value, then I'll get a new value. Okay, so let's say this new value is 6. So what I'll do, my y becomes, I will discard this one, because I have already seen how this in the previous iteration I have already used this one, right? So now I'll discard this one, and I'll start with now in the next step when 6 comes, now in the next step when new data comes, which is 6, my new array will become what? I will discard this one will be thrown out of the data structure. So now in the next iteration my array will become 2, 3, 4, 5, 6. Now I'll plot this. Okay, so initially I plotted 1, 2, 3, 4, 5, then I plotted, then new data came 6, I discarded 1, my array became 2, 3, 4, 5, 6. Now I'll plot this. Okay, so then plot, and then again a new value comes. So what will happen in next step? 2 will get lost. I will discard this 2 from the left hand side. Now the data array becomes 3, 4, 5, 6, and now my new value comes in place of 6, I have the new value, which is 7. So this is my updated array. Now again I'll plot. Then I'll get a new value. Let's say it is 8. So what happens in the next one? I'll get, now 3 will be discarded, 4, my new array will be 6, 7, and 8. Again I'll plot, and again I'll get a new value. Let's say it is 9. So now what will my array become? 4 will be discarded, 5, 6, 7, 8, 9. And I'll continue this. I'll continue like this. So if you see carefully, if we see the traveling of this 5, so we started with 1, 2, 3, 4, 5, 5 was on the rightmost side, then it came here, it moved to the left by 1 position. Then again when the updation happened, it moved to the left position by 1 unit. So every update step, every element is moving towards left by 1 unit. Then 5 came here, then 5 came here, and finally 5 will be also discarded, because my array size is fixed, right? The size of my array can only hold 5 values at a time. But the important thing over here is my data is changing. So my data, I started with 1, 2, 3, 4, 5. If you see after the 5th iteration or the 5th updation step, 4th updation step, my data is now 5, 6, 7, 8, 9. So my data is getting changed, right? It's not a static array, it's a dynamic array. From one side I am taking new values, and from the other side I am continuously pulling out values, right? So each step one new data point is being added. So this is the working of scrolling plot. Like if you take a very basic array and if you do the scrolling plot and like if you want to take an example of scrolling plot on a very small array size, then this can be taken as an example, right? So this hopefully explains you the concept of scrolling plots. So we started with the definition of basic plots. What are basic plots? Hopefully you know what are basic plots, and then we discussed how this can be recreated, how this plotting technique can be recreated to get new values every time. Okay, so now we have defined what are scrolling plots. So I'll also try to make you understand about the requirements and setup and everything. So before we jump into that, I want you to see one more thing, what essentially I am doing. If you see from step 1 to step 5, in each update is every time the array is being updated, what operations are being done. So if you see, I have in the first updation step, I have 1, 2, 3, 4 and 5, right? Now I have to discard 1 or the leftmost item and add a new item. So what I am doing is, I am slicing this part of array. So I am slicing this part, which is index 1 till the end. Okay, what is end? N minus 1. In Python it is defined differently, but element wise if we see, this is 0 index, this is 1, this is 2 index, this is 3 index, and this is n minus 1, which is 4 index. So what I am doing is, I am slicing everything. I am slicing this array into two parts, right? One is the 0th part and the other is starting from index 1. And what I have done is, I have taken this second slice which starts from index 1, and I have copied it to index starting from index 0. So everything gets shifted to one place to the right. Right? So I have sliced this part except the 0th index, which is 1, 2, 3 and 4. I have sliced this part and I have copied it to elements starting at 0th index. So this index will also get updated, this index will also get updated, this value will, similarly you will have these updated indexes, and now you will have one index left on the rightmost part where you can have the updated value, because the array size is fixed. You can hold only 5 elements at a time. So that's how we keep track of important data points that we discard, because we are taking only one we are getting only one new element at a time. So that's how we are discarding this one. We are making a copy of the rest of it starting from 0th, so that we have a vacant place at the rightmost position, and then we are assigning it to the new data variable, which is the new data point, right? So I hope the transitioning is clear. Definitely when we'll implement it, it will become more clear, right? Okay. So this is how scrolling plot works. So yeah, moving ahead. Now we'll see the requirements. Okay. So one of the requirement is Pyqtgraph. Okay, which is a library. Other requirement is numpy to hold data. Okay, this is for implementation of graphs. And other stuff. Okay. The third one is Pyqt5. This is also a library because Pyqtgraph depends on Pyqt5. It has some dependencies of Pyqt5. You can also use Pyqt6, but for this tutorial I am going ahead with Pyqt5. So, and the last one is Jupyter Lab. So this will be basically like your local environment for writing code. Okay, so these are the dependencies, or these are the requirements which our project will need before we get started. So let's get started with the installation of these things. So I'll go to my terminal or command prompt in Windows. So now I'll install these dependencies one by one. So first I'll do Pyqtgraph. So I'll write py-m pip install Pyqtgraph. Okay, so this is the command. Now I'll press enter. Okay, so it says requirement already satisfied. If it is not installed on you, because I have pre-installed Pyqtgraph on my system, if it is not installed, the installation will begin, and you don't have to do anything. Just you have to give this command. The second one is Pyqt5. So the command remains the same. You just have to, instead of Pyqtgraph, you can just give Pyqt5. P and Q are capital. Press enter, and it's done. If it's not installed on your system, it will go ahead with the installation. Otherwise, it will say requirement already satisfied because I have pre-installed, right? Then you can also go ahead with installation of numpy if it is not installed. So same command, py-m pip install instead of. So you have to give the library name. So I'll give numpy. So it says requirement already satisfied. Again, if it's not installed on your system, it will get installed. The last part is Jupyter Lab. Okay, so we need Jupyter Lab because it's an environment where we will code. So again, I'll do pip install Jupyter Lab. Okay, press enter, and it says, as you can read, requirement already satisfied. Because I have pre-installed, if it's not installed, again it will get installed. No need to worry. If you face any issues in installations, some commands don't work, or it throws any error. If you face any issues, then you can comment down your errors, and I'll look into it and I'll reply back to you. Okay. So the installations are done. Now let's start Jupyter Lab. So I'll give the command Jupyter -lab, Jupyter Lab. Press enter, and as you can see, it will redirect you to a Chrome tab. Okay. Yeah. So it's nothing but an instance of your local machine with this environment, with this UI, so that you can start with the coding. And here we can execute cell by cell. So that is the advantage of using Jupyter Lab. So because I want a notebook, I'll click this Python 3 notebook option. Okay, so once I click, the environment is loaded, and this is the editor where I can write my code. Okay, let's just give a simple print statement, not print statement, let's just add something, 5 plus 3, and it gives us 8. Okay, so everything is working now. So now we'll get started with the coding. Okay. So first step is I'll import the libraries. Import numpy as np, right? And the second library is import Pyqtgraph as pg. You can give it any name. I'm just giving it pg. And let's just run this to see if there's any error or something. No, there's no error. Okay. So now we will start with the coding. Now, what is the flow basically to create a scrolling plot? So we'll just discuss that once. How things work in Pyqtgraph is basically we'll understand. So first of all, you have a window. Okay, so this is my window. This is basically the layout. I mean, it's not a layout window. It's just a UI window where everything you code will be presented. Inside this, so let's not call it window because again we will be using Windows name. So this is basically just like a UI. Okay, a UI app. Now inside this we will have layout. This layout is what is Windows. This is a single window. I mean, like this screen is a window, so basically it's a layout. Now inside this layout we will be, so this layout is graphics layout widget. Now what is this graphics layout widget? It's a layout where you can lay different elements. Your different elements would be plots, curves, images, text, right? So all these things you will constitute your UI app, right? So all these items will be placed inside this window. So your items can be graphs, images, and text. Okay. So now, what is this graphics layout? It's basically a grid. And what is the grid dimension? So let's say I have drawn here 2 cross 2 grid, right? So this dimension depends on how you have coded, right? So initially it will be just a single window, like 1 cross 1. There will be just one cell. But if you want, you can make this one cell as a parent cell and have child cells. Okay, so definitely the starting point will be just one cell. Okay, so the starting point would be just this single cell. Okay, now if I want divisions, let's say I have just one graph. Okay, I add that graph into this Windows layout, so that graph will get displayed. Okay, this will be my graph. Now let's say I want 2 graphs, then how will it happen? So then it will divide this into a grid of 1 cross 2. So here you can have one graph, this will be your one curve, and here you can have the second curve, or you can also have like this. So here you will have one graph, and here you will have another graph. So it depends on how you want your UI elements to be placed. So this graphics layout is basically, it gives you a grid based layout, right? Where in different grids you can place different UI elements according to whatever you want to create. Okay, so since we have only one, in this project we will be only displaying one simple scrolling plot. Our layout will have just one grid, okay? It will be a 1 cross 1 grid, and simply our graph will be displayed, whatever we place. Okay, so now we have discussed this much. Now we'll move ahead to implementation. So now first we will need the layout, right? So I'll name it Win because it's basically a Windows layout, right? So you can name it anything. I mean, just for better understanding, I'm giving it the name Win. So how it is implemented is pg.graphics and layout. So the method is graphics layout widget. Okay. The method is graphics layout widget, and there are two parameters. Now, first parameter is show, which you want to set to true because you want to show the layout, and you can set it to false if you want to hide it in the starting or something like that. So that scenario. And the second parameter is a tuple of size 2, and the parameter is also size. Now, what is this size? This size is the size of this window in pixels. Okay, so your screen would have some resolution, right? So it is 1920 to 180 pixels. So same way, how much your graph will occupy, how much pixels your window will occupy on the screen, that is the screen parameter. It is width is to height. Width is your so this length is your width, and this length is your height. Okay, so it is width is to height. So let's give it 900, 400. Okay, we'll change it also to see if things are getting changed or not. Okay, now I'll add a certain a suitable title. So I'll use the set window title. Set window title, and it's basically just like you can see Pyqtgraph is appearing on this tab window, right? You can see Untitled 5. So this is like the title of this tab. This is Pyqtgraph is title of this tab. So similarly, you will have title for this window. So I'll give scrolling plot example. Okay. Okay. So now my title is done. Now the second thing was to add a graph. Okay. So inside this window, I'll add a graph or plot. Okay. So I'll use add plot method dot add plot method on, I'll call the add plot method on Windows object, right? So that will create plot object for me. Okay, I'm naming it P1 because there is only one plot in our example. Okay, now we will need a data structure to hold our data, right? So I'm defining it as a NumPy array. So initially I'm taking the size to be, for simplicity I'm taking the size of the array to be 5 elements. We'll just take 5 elements and then will increase. So data 1 is my array, this array. So we discussed, right? Yeah, this array. So this array is basically holding my values. We'll have to update this array only, right? Okay. Now I'll give a print statement saying data array before updation begins. So this is just like a log because we want to see things happening before updation process begins. So I'll do it like this, comma, and I'll just print data 1. Okay, this will just only print data 1 and with a statement that before updation begins, this was my data. Okay. Now plot is added. If we go back to our discussion, now we have Windows object, we have the plot object. Now we need a curve inside a plot object, right? So our curve will be this thing. Whatever values will be drawn, we need an object for that, right? And to that object we'll set the data 1 as the data structure, so that our curve knows that okay, I have to plot, I have to take shape of this data structure. Okay, so I will create a curve object and I'll call it on P1 because P1 is my plot object. So you can see the hierarchy, right? First it's Windows, on Windows I call the plot object, and then on the plot object I call the curve object. So there I will pass data 1, and this is the first time I am plotting. Okay, this will take the data 1 and it will set it to curve 1. So initially whatever values will be assigned using NP random normal will be plot. Okay. Okay. So now I'll take a count variable so that I can keep the track of the updation step which is going. It will get clear in a while. Okay. So now all the necessary declarations are done. Now I'll define an update method. Now in this method, I want my data structure to update. Okay. So first thing I'll do is I'll set the data 1 and my count to be global. Why global? Because I will be making the changes inside to this data 1, right? My array will be changed, and I just don't want those changes to be inside update, right? Those whatever changes I make inside update has to be available outside. They need to be accessed. They need to be those changes need to be accessed by the outside functions, right? So that is why I have defined data 1 and count to be global. So that if I don't define them as global, then my whatever changes I make inside this update function won't be accessed outside the update function, right? So because I want those changes outside of the update function, I am declaring them as global. Next, what I'll do is I'll increment count by 1, because count is keeping track of the updation step. This is the first updation step. This is the second updation step. This is the third updation step. So I need to increment it by 1. So I've incremented it. Now I'll update the data. So what I'll do, first we'll write and then we'll understand what is happening. So we have already discussed this. Like if you'll give it at some time, you'll definitely understand what I have written in this line. So what I have written, this is where I update my data. I want the new value. So we discussed here, right? We started with some values. I want the new value and I want to discard the leftmost point, right? So what this will do is, first it is taking data 1 till the last element. So it will take data from index 1 till the last. So it will take 2, 3, 4 and 5. It is slicing, right? It is slicing 2, 3, 4, 5 and it is keeping it as a slice. So that I have assigned to data of starting till -1. So what is -1 index in Python? -1 index is the last element, right? The last, like if we just, I'll explain this once again. Yeah. So if I have like array 1, 2, 3, 4 and 5, this is my first index. This is till the end. This is my -1 index. Okay. So first what I've done is I've taken data from first till the end, first index till the end. So I've taken this part and I have copied it to data of starting point till -1 index. So it will basically take 2, 3, 4, 5 and it will place it from here, from the starting. So what will my array become? 2, 3, 4, 5 and this value will be left. And in this value, because now 1 is discarded, right? Because in place of 1, 2 is there. Because I have sliced and I have copied it, right? So in place of 1, I have 2 now. In place of 2, I have 3 now. In place of 3, I have 4 now. Everything is shifted to left by one unit. In place of 4, I have 5 now. So in place of 5, now I can take a new value, right? So in place of 5, and how I can access that fifth element? -1, because -1 is the last element of any array, right? In Python, -1 represents the lastmost element or the rightmost element. 0th element represents the element on the leftmost, -1 is the lastmost. So now I'll take a new value. So np.random.normal. So np.random.normal will just give me one single value, one randomly generated single value, and I have updated it to, I have assigned it to data of -1. So now in place of this, I can have 6, or I mean, for example, I'm showing 6. It will give whatever np.random.normal generates. So now my updation is also done. I'll just print now that, because I want to see how my data is changing, data array after, I'll put in count in here, data array after this much updation is updation step, after this updation step, right? So this space this dot format. So dot format you use when you want to fill in some variable into print statements, right? So in place of this curly brackets, count will be printed, comma data 1. So this will help me visualize. Okay, so this is my print statement done. Now the last step is now my array is updated, my data structure is updated. So I'll just set that updated data structure to my curve. Okay, so I've been missing one thing. I've assigned it data, I've declared data 1, right? So here I cannot write data, I have to write it data 1 and data 1. Otherwise it will throw an error that data is not defined, right? Okay, now it looks perfect. My update function is also done, right? Now I need something to call this update function after some time, right? After some time, let's say after every 100 milliseconds, after every 500 milliseconds, after every 1 minute, after every 10 seconds, this can be the time duration. So after this much time, I want something to call my update function, right? So for that purpose, I will create a timer, and the timer can be accessed using pg.qtcore.qtimer. Okay, so this is how I create a timer. Now I'll bind this update function. Okay, this update function I'll bind to this timer object. So timer dot timeout dot connect, and here I'll give update. Now what this line what it did, it created a timer object. In this line, I'm binding this update function to this timer object so that it knows I have to call this update function, right? And after how much time? that I will give in the start parameter. So inside this I'll give 10,000 millisecond or 10 seconds. Okay, so what we have done in these 3 lines, the first line I have defined a timer, the timer object. Second line I have binded this update function to my timer object, so that after the timeout it knows that I have to call this update function. And in the last step, what we'll do is we will start this timer so that the timer starts counting, and it knows that I have to fire this update function after this much time. The parameter given in the start method is the time after which timer will repeatedly call update function. Okay, so every 10,000 milliseconds or 10 seconds, after every 10 seconds it will start calling the update function, and it will do it in a continuous loop. Okay, so for that we don't have to implement that loop, because that loop is already implemented in these methods, right? We just have to call those methods. Now our app is, the coding part is done, so I'll just execute this app. So I'll write if name equals main, then just execute my app. And how will I execute? By calling the pg.exec function. Okay, so this is how I will execute my app. Okay, so everything looks clear, everything is done. Let's just run it. Okay, so it is giving the error. Okay, the error is in the time.start line number 26. So it is saying that time is not defined. Obviously time is not defined because my timer object is timer. I have named it as timer. So I am missing an R. So I'll just correct it. I'll make it timer. Now let's execute it once more. Okay, so it has printed that data array before updation begins is this much. So this is my initially the initial value, right? We initialize data 1 with this. So this is my initialized value. Now let's see how the plot is looking. Okay, so this is my plot, and let's just see if it is updating or not. Yes, it is updating. It is updating. You can see that the points are moving from right to left. The updation is happening in from right to left in this direction, right? So this is our window. Inside the window we have a plot object. So those plot object will create these x-axis and y-axis and these values, and this curve is basically your data structure, right? Okay, so now it is also printing that in the starting we started with this array. After first updation step, the array became this, after second, after third, fourth, fifth, and so on. After 8th updation step, and it will continuously go on because it is executing in while loop. And our data is also getting updated after every 10 seconds. Okay, if you see this graph, it will move from right to left. Every 10 seconds it will get a new value and it will update the plot. Now if you see carefully, when the data, we started with this array, right? Now what was the last element in this? 0.10394086. This was the last element. After first updation step, this element got lost, right? This was the 0th element, this 0th index element, this got lost, and everything shifted to left by 1 unit. So 0.20277026 came to the 0th index, 1.54619345 came to the first index, 0.54725642 came to second index, and similarly this element also got shifted to this. It from fourth index it shifted to third index, so that we can have a new value, and this was our new value. Similarly, in the next step, this element got discarded and then everything got shifted to left by 1 unit, so that we could make room for the new value, right? So the new value is coming every 10 seconds. So as we can see, we have done 19 steps. So, and this is how the curve looks like. And the screen has occupied the window, this curve window, the plot window has occupied how many pixels in width? 900 pixels in width and 400 pixels in height. Let's just update some of the parameters so that we can see the curve updation at a faster rate. So let's just make it even bigger. So I'll make, or let's make it smaller. So I'll make width as 500, height as 400, okay? And I'll also increase the number of data points that I have. I'll increase it to 100, or yeah, let's fix it to 100. And instead of this 10,000 milliseconds, I'll give it 100 milliseconds. So now after how much time it will update? After every 0.1 second, because there are 1000 milliseconds in 1 second. So after every 0.1 second, it will update the graph. So the updates can happen at a faster rate. Okay, let's observe what we see. Yeah, so this is how the graph looks like. You can see that I changed the size parameter, so the window has also become smaller in width, though height is same. The number of data points are the numbers that are displaying on x-axis. So 100 is getting displayed because there are at any point of time you will have only 100 values, okay? But the last value is getting updated, the leftmost is getting discarded one by one after every 0.1 second. So that is why the plot is appearing to move from right to left. So now because we updated from 5 data samples to 100 data samples, initially it was showing only 5 samples on the x-axis, now it is showing 100 samples on the x-axis. So this is how the updation looks like. You can play ahead with the parameters and stuff, and you can see what you can create. Now this can find applications where you have like a streaming data. You have a stream of data which is continuously coming to you and you want to analyze that data. So in those scenarios you can probably use this kind, and you can create a simple dashboard kind of stuff so that you can see and analyze data, right? So one application, one example I'll give you. For example, when we launch any satellites from Earth to orbits, those satellites, they have like tons of sensors. They have accelerometers, gyroscopes, and they have lots of data, right? Which they send back to us to the base station. So, and then we analyze that data, and with the help of that data, with the help of those sensory data, we make sure that okay, the satellite is on the right trajectory or not. So to analyze those data, to analyze those complex kinds of data, we create these kind of dashboards where we analyze, right? That okay, this is everything is in check, nothing, there are no faults, there are no alarms or something. So everything is working functional or not. So this can be one application. Wherever you have the need to analyze and monitor the live stream of data, there you can find such, there you will find scrolling plot has an application, has a use. Okay, so I guess today's lecture was helpful to you. Maybe you'll be able to create something out of it, you'll be able to create something meaningful out of it. And this is about scrolling plots. This was just a basic lecture about it. and we'll explore more about it also in the future videos. So that's all for today. If you have any comments, if you have any doubts, just comment them down below. It can be any doubts related to this session, or it can be any doubts related to Python. I'll be happy to take them forward, and I'll be happy to reply to you and make sure that I solve your doubts and queries. So any doubts related to anything, this session or anything in general, you can just post them as a comment, and I'll reach to every one of you individually, so that I make sure that I have answered all the queries. So that's pretty much it for today's session. We'll close it up here, and I'll see you in the next one. Take care, stay safe until then. This is Utkarsh Pandey. I'll see you in the next one.